Hey Defenders, welcome back. In this video, I want to discuss how we can use Elasticsearch to automate our log rotations, right? So as we start to ingest data and store it, whether it's on disk or if you're writing your logs to a file share, right? Eventually that you're gonna run out of space, right? We have our limitations in terms of how much space we have allocated to either an SSD, spinning disk, or a file share. And what we will go over in this video is how we can automate log rotation, so we can automatically wipe out the old logs that may be above our threshold of how long we want to store them. So stick around and we'll jump into it. But first, time for my shameless plug. If you want to learn more about our company, head on over to opensecure.co. If you would like to hire us for a project, select the Hire Us button at the top of this video. To see firsthand the power of open source technology, take advantage of our interactive demo. Select the demo button and start exploring. Now let's get back to the video. So now that we have our Elasticsearch, Kibana, Wazoo Manager, Wazoo Agent, and FileBeat all installed and our infrastructure is there, we're now starting to collect logs, which is great, but there will come a point to where we'll start to max out how much disk space we have available, right? So, and then all of a sudden, if Elasticsearch can't store the logs it's receiving to disk anymore, then the service will fail, and we're going to miss out on any logs that we should be collecting, right? And if you let that go for a few days, that could be very problematic and could bring down your whole infrastructure and leave you blind as a whole, right? Which is something we don't want to do. So what we can do is set up what Elasticsearch calls a index lifecycle policy. And this will be a policy that we can set that will rotate our logs for us automatically, right? So if now that we're starting to receive our logs, if we go into stack management and we go into index management, we can see the logs that we're starting to store, right? And very elementary way of thinking of it is all of our logs for a given day are stored to an index, right? And so that's how Elasticsearch stores its data within indexes. And Wazoo by default has these indexes rotate to the next index name once a day, right? So you can see here for every date we have a different index, right? So we can see those change accordingly, and we also see the storage size. So this being just a demo box, we have very little data, but in a enterprise environment, you could have hundreds of gigs and even up to terabytes worth of data that you're storing, right? And depending on the longevity of how long you need to keep that data, maybe you have SLAs that state that you keep all security data, security related logs up to a year's time, right? And you need the ability to hang on to that, but you also don't want to keep 2 years worth of data, right? So you could either write them to backup tapes and ship them off somewhere, and then when you need to retrieve the data, you could do that. That's of course a long process, and there's many parties at play there. So what we can do is with Elasticsearch implement a index lifecycle policy that'll handle this for us, right? And so we have our indexes stored, right? If I were to actually get on the Elasticsearch server, so in my elasticsearch.yaml, right, we specify when we first deployed this our path.data. So this is just a local directory here that I have mounted. And so if I go into that directory, it won't be very pretty on the eyes, and Elasticsearch stores them kind of weird. But if I go into indices here, I'll see all the indices that Elasticsearch has written to. And I know our the indices names that we see in the web UI isn't what's correlated to Elasticsearch. That's just what's saved on the server itself. That's just how Elasticsearch handles it. So I don't know. I assume these are maybe some hash values or something. I don't know. But that's how Elasticsearch is handling it under the hood. But thankfully, when it presents it to us within the UI, it's a name that makes sense to us, right? All right, so we have our indices here. What we can do is, and I'm under the stack management tab here, is go into index lifecycle policies. And you can see a few are created by default. I want to go ahead and create my own, and I'm going to create them for, let me go ahead and duplicate this out, for our wazoo-alert indexes, right? So these guys here. And if I also go into, all of our indexes come with a template, right? So if I go into this index template, you can see by default with this wazoo template, you can kind of think of it as an alias for our wazoo-alerts 4.x-wildcard index patterns, right? Which is all of these guys here. So if you guys should be familiar with index patterns now if you follow along with the visualization Kibana video that I put up the other day. And so now we have, so this should all be populated by default. If you need to create a template for whatever reason, you could go ahead and do that. You know, say I want to say wazoo 2, and I won't actually create it, but then it's asking us to match on a index pattern, and it would be wazoo-alerts-4.x-star. And I'll go ahead and back out of that but this should already be created for you. So we'll then go into lifecycle policies, and we're going to go ahead and create a policy, and I'll call it delete after 30 days. And this policy name can be whatever you want. They have a few characteristics you have to follow, like you can't start it with an underscore, and you can't have a question mark or space in between the name. And then you see we get to our phases. There's a hot phase, a warm phase, a cold phase, and a delete phase. So Elasticsearch is very memory intensive, right? It's under the hood, it has a Java VM that's running, and in terms of resources that Elasticsearch is mostly consuming, it's mostly RAM. So that's why in the previous videos back when we were first deploying our Elasticsearch server, you want to allocate it a healthy amount of RAM so that it can keep up, right, with the logs that you're ingesting and perform all of its tasks. So these phases here specify where they reside in memory, right? And I don't really want to get too into it because we don't need to fully understand the ins and outs of how Elasticsearch is accessing memory in order to set a policy. And you can see under these phases they have some descriptions, right? So you can, for the hot phase, they're saying you are actively querying and writing to your index. So these will be your most recent indexes, right? Maybe today's the April 1st. Shout out April Fools. Leave in the comments section what the greatest April Fool's joke you ever did was. I'd be curious to know. But getting back to it, so a hot phase would be like today's index or maybe this week's indexes, right? So this is data that I want to be able to query very quickly within Kibana, and I want to view this data quickly without Kibana potentially timing out. And then we have a warm phase. So this warm phase is read-only, right? They're specifying you can allocate shards to less performant hardware. For faster searches, you can reduce the number of shards and force merge segments. So I like to set this for like 2 weeks back, right? So indexes that are within the 2-week phase are 2 weeks old, right? Are stored within this warm phase, and we're still able to read this data with Kibana and query on it, but it'll be a little slower, right? And then we have our cold phase. So they're saying you can allocate shards on significantly less performant hardware. Because your queries are slower, you can reduce the number of replicas. So if I have like a cluster of Elasticsearch servers, maybe I have like 8 servers within my cluster, and maybe 2 of those servers, maybe I'm running out of resources that I can give those servers, right? If I'm spinning them up on a big VMware box, right? If they're all virtual servers, maybe I'm running out of CPU and RAM I can allocate to these two new servers. So they're not going to be as resource intensive. Or maybe I'm buying hardware for my Elasticsearch servers. Every one of them is a new piece of hardware, and I spend significantly more on 6 of the servers, right? And that, of course, that'll cost more out of my pocket, but they have much more CPU and RAM allocated to them, where these 2 other ones I couldn't afford as much, so they're significantly less, right? So there you have less resources allocated to them. And so that's where our cold phase indexes would be moved to, right? So we can still query them, but it's going to be a lot slower. So what they're kind of advertising here is you're querying your index less frequently. So really, these are kind of indexes that are out of sight, out of mind by now. Maybe these are a few months back, but all of a sudden, a customer is asking for logs from, a few months back, or maybe you had a breach and you want to check logs from a few months back to see what happened. You can do that here. It'll just be slower. And then we have our delete phase. And this is where our index rollover really comes into play. So, let's say, so for this demo, we'll have a delete after 30 days. So I'll go ahead and set this guy to delete the index after 30 days. So once an index hits 30 days old, Elasticsearch will remove it and clear that disk space that it's taking up. So it'll clear out for new indexes that are more current and more relevant to me, right? So we can go ahead and move through these phases here. So the hot phase is required. All these other ones are optional. Which is nice. So depending on how sophisticated you want to get with it, you can move throughout the phases. If we first have a maximum index size, so this will, enabling a rollover will dictate when the index will move over to the next one. So let me get a good example of this. Let me do storage size. So right now we're rolling over every day, right? We have the 30th and we have the 31st, where if I set, let's say for this maximum index size, I'll set it to 10 gigs. That may be a bad example. I'll do 10 megabytes. That's a little more realistic for, I'll do 1 gig. And so we have that set. So once our storage size of an index hit 1 gig, it would automatically roll over, right? And it would take a new index name. So once we hit 1 gig, the index would roll over and it would create a new one, and all of the recent logs that Elasticsearch is receiving would be written to this new index until that index, until either the day ended or that index also hit 1 gig, and then it would roll over to the next one. So with this hot phase, this enable rollover function, we're specifying the maximum size we want the index to be before it rolls over. We can also set a maximum age if we want. So maybe it doesn't hit 1 gig, but we want it to roll over in a day, right? Or maybe we want to roll over every hour. Elasticsearch will now, whichever comes first, roll over for us. So it'll either hit a gig first of storage of size and it'll roll over, or it'll become 1 hour old and it'll roll over. And then we can set our priorities. So if you have a big cluster and maybe you want to prioritize how quickly you're retrieving back indexes that are maybe stored on less resource intensive servers, we can set that priority here. But I'm not going to worry about that for this. So for this, you can just leave it at 100. We then have our warm phase that we can set. So we enabled the button here to move to warm phase on rollover. So this is specifying because we've enabled the rollover. So we'll move it to the warm phase after that. We can set a number of replicas that we want. So replicas being Elasticsearch does data index replication under the hood. So if you were to, if one server were to completely go down within the cluster, that a replicated index of that same one that you may have just lost would be stored on another server, so you wouldn't lose access to that data, right? So it has a fail-safe in it for that. But we can specify if we want to either shrink the number of replicas or increase it, depending on your data retention needs, right? So we can do that there. We can then shrink the index so we can make it smaller. So what'll happen is when an index reaches a gig or 1 hour of age, it'll move over to the warm phase, and it'll actually move to a new index name, and it'll be prefaced with shrink dash wazoo dash alerts and then whatever the date is. And that shrink will actually shrink the size of the index, right? So instead of, maybe once we hit a gig, so instead of a gig, it takes a 0.75 of a gig, and it'll shrink it and give us more disk space that way. So you can kind of play with it to where, maybe you want to store a year's worth of data before you roll it off and remove it and make space for new indexes. Well, what you can implement the shrink policy, so it'll shrink older indexes that you don't really need to access at the moment. You can shrink so they take up less disk space and you have more room to store your logs. And then you can also set a priority, which is similar to what we have in the hot phase as well. We could then move to a cold phase if we want, and we can specify the timing for the cold phase. So we rolled over, and then we can specify when we want the cold phase to become active. So we can either do it 0 days from rollover, so immediately, and skip this warm phase altogether, or we can do, we can let it hit a warm phase, say 1 day from rollover. So an index rolls over, a day expires, and then we hit this cold phase, right? And then what we can also do is take advantage of the freeze index. So and they describe it a little bit here. So they're saying a frozen index has little overhead on the cluster and it's blocked for write operations. So you can search on it, but they tell you that it's going to be slower. But you can, what this is doing to Elasticsearch under the hood is this is freeing up memory that it can allocate towards new indexes that are needing to be stored and needing to be queried by Kibana, right? So we can, while we're not saving up disk space, right, we're not shrinking it or anything anymore, we're freezing it so that we're able to allocate more memory to our current Elasticsearch actions that are going on. And then we can also set an index priority here. And then we have our delete phase. So I'll go ahead and activate this, and we still have our days from rollover thing. Since in this example, we're going to delete an index after 30 days, I'll go ahead and set this value to 30. And then snapshot policy name will leave blank. That'll be in the works for another video where I'll talk about snapshots, so stay tuned for that. And then we'll go ahead and save. And okay, it looks like it's giving us an error. Shrink the index to a new index with fewer primary shards. Oh, okay, they want a number. So I'll just say 1. And we'll try that again. All right, and now we have our new policy. So now what we need to do is we need to link a index template to that policy, right? So I have this policy created, but now I don't have any indexes assigned to it. So none of them are going to roll over or freeze or delete until we assign them to a lifecycle policy. So that's what we can do here under the Actions tab. So I'll say Add Policy to Index Template. We can go ahead and select a template, and this will mimic what we have in our index templates, right? So we have this Wazoo template, which correlates to these index patterns, and we can set that, and then we're asking for an alias for rollover index. So I'll just say wazoo-rollover. And we'll go ahead and add that policy. So now any indexes that are created within new indexes that will be created will be assigned this policy, and they'll be linked accordingly. And we'll take the appropriate action as they move throughout that policy, right? So as they get older, and once they hit that 30 days, they will then be deleted automatically for us. And so let's see if we can set this policy to old indexes, right? And we can do that. So let's click on maybe an older one. So I have this one from January. So if I select this index, I manage it. I can then add a lifecycle policy. And let's go ahead and select one, and we'll select our delete after 30 days. And we don't have an alias, but that's fine. We can go ahead and add it. And now we see the setting, the index lifecycle name is set to this guy, right? And so this one, of course, will move through the lifecycle phase very quickly. But say you have a lot of indexes here, and you want to apply it by bulk, right? So you have a lot of past indexes. You didn't set up these lifecycle policies when you first deployed Elasticsearch, and you want to mass deploy it. So I suppose you could select all, and no, you can't. Okay, you can't do it from the UI. So what we'll go ahead and do is go into the dev tools and interact with Elasticsearch's API. On the dev tools, and I have to dismiss that. There we go. Okay, and we'll go ahead and write a put request. So we'll say put, we'll say wazoo-alerts. You can see these starting to pre-populate 4.x-star. So I'm saying everything, and I'll do an underscore of settings. And what we will do is add a bracket. I'll add some spaces here. We'll specify index. And we'll go ahead and set a lifecycle .name. We'll go ahead and set that to our lifecycle name, which was this guy, delete after 30 days. And let me add these quotes. And we need to add our last bracket. And let's go ahead and run that. And so now we've applied this lifecycle, right? So we took the step that we just did before, but now we've applied it to all previous indexes, right? So now all of our previous indexes and our forthcoming indexes will be applied the same policy. So thankfully we can make a easy API request through the UI, which is actually pretty nice. You don't have to do it from a command prompt or anything like that. And we can now set a lifecycle policy accordingly to match our needs. And we can prove that. Let's go into one of these other guys, one that we didn't select. We'll do this. See if we select this guy. And you see the lifecycle policy is set. So here you can see our API request worked and worked accordingly. And you can see it's on the rollover action, right? Because this is an old index. And then Elasticsearch is now rolling it over, and it'll move through the warm and cold phase very quickly, and will then be deleted as necessary. So I appreciate you guys hanging out with me. If you have any other questions, leave it in the comments, and I look forward to hanging out with you guys in the next video.